The Saab Gripen just transformed from a budget-friendly fighter into something defense analysts can barely categorize, and the force behind this transformation is not Lockheed Martin and not Boeing, it is Rolls-Royce. For years, the Gripen E existed in a very specific category, a Generation 4 fighter designed for nations with limited budgets, operating costs around $8,000 per flight hour, simple maintenance requirements, and the ability to take off from 800-meter highway sections. It performed well in harsh northern European conditions and offered NATO compatibility without the astronomical price tag of American alternatives, but it remained just that, an alternative, a compromise, a cost-effective option without the cutting-edge performance of billion-dollar programs. Then Rolls-Royce entered the engineering room, not to replace the General Electric F414 engine, not to announce a revolutionary new propulsion system, but to redesign what already existed inside it. Internal airflow channels, thermal airflow, distribution layers, control algorithms, and components so deeply embedded that external inspections revealed nothing. Sweden kept the program classified. NATO was not informed, and when the first performance data began appearing in Alliance, monitoring systems analysts assumed their equipment was malfunctioning. The numbers did not make sense. Heat signatures were dropping to levels only stealth aircraft achieve. Range was extending beyond what single-engine fighters should be capable of, and acceleration profiles exceeded anything recorded from previous Gripen variants. NATO recalibrated their measurement systems, but the anomalous readings remained. A single-engine aircraft was performing nearly like a twin-engine stealth design, and this should not have been possible with publicly available technology. The first breakthrough involved infrared signature reduction. Every fighter jet generates heat from its engine, and infrared sensors detect this thermal output from long distances, while infrared-guided missiles use this signature to track and engage targets. Rolls-Royce redesigned the entire thermal routing system inside the F414 engine, and the result was dramatic. The Gripen E reduced its heat signature to levels far beyond the capability of any single engine. Aircraft previously developed. NATO recorded unusually low infrared readings during joint exercises and initially suspected sensor malfunction, but after equipment verification, the results remained identical, an aircraft lighter and cheaper. Then the F-35 was producing thermal signatures comparable to advanced stealth platforms. The second transformation involved fuel combustion efficiency by redesigning internal air pathways. Rolls-Royce enabled the engine to extract significantly more range from standard fuel loads. The Gripen E operational radius increased to levels that traditional endurance metrics required two engines to achieve, and for countries like Canada with vast Arctic territories, this capability changed procurement calculations. Completely long-range patrol missions previously demanded heavier and more expensive aircraft, but now a platform lighter than the F-35 could fly nearly identical operational distances with greater agility and drastically lower operating costs. But the most shocking upgrade remained hidden inside the digital engine control system. Rolls-Royce developed a new adaptive response model that allowed the engine to adjust thrust output faster than any previous system. The acceleration, the profile became almost instantaneous. Pilots reported the aircraft lunging forward in ways they had never experienced before, and in air combat simulations, this created major problems for older NATO interceptors. The Gripen could escape dangerous situations or seize attack positions before opponents could react. Sweden kept the simulation results classified, but NATO eventually accessed enough performance data through joint exercises, and what they discovered forced them to rewrite tactical playbooks. When these three factors combined, reduced heat signatures, extended range, and faster throttle response, the result was not incremental improvement. The Gripen E jumped into a completely different performance tier. An aircraft that cost the fraction of stealth programs suddenly competed directly with billion-dollar platforms, and everything was achieved without changing anything visible on the exterior of the engine. On paper, specifications remained identical, but in practice, capabilities were fundamentally transformed. Multiple NATO members demanded clarification, and closed-door meetings took place in Brussels. Swedish officials provided vague responses, avoiding disclosure of specific technical details, and only confirmed that the Gripen E had undergone internal improvements aimed at optimizing performance. The truth about Rolls-Royce involvement emerged later through internal documents, when a NATO analyst cross-referenced engine vibration signatures with known engineering patterns. The two quoted micro-vibration data matched internal components, built according to Rolls-Royce precision micro-engineering program, and when this evidence surfaced, the implications became clear. Sweden and Rolls-Royce had collaborated secretly at a level that bypassed NATO's usual oversight of fighter development. The strategic concern spread rapidly through Western defense circles because if affordable fighter jets could suddenly compete with the most expensive aircraft in the world through invisible internal upgrades, then the entire export control framework faced obsolescence. Traditional oversight policies could not track modifications that left external specifications unchanged. American officials began issuing warnings in classified briefings, describing the Gripen as an unpredictable strategic wildcard cheap enough for smaller nations to afford, powerful enough to threaten heavily protected airspace, and capable of rapid scaling without approval or oversight from Washington. Additional upgrades emerged as NATO investigated deeper. One discovery involved airflow pressure modulation. Rolls-Royce created a system that allowed the Gripen to operate with exceptionally stable thrust at high altitudes, enabling the aircraft to climb higher, maintain altitude longer, and burn less fuel in the process. This was achieved using an internal vane system that reacts in milliseconds to pressure changes without modifying official specifications. Pilots simply reported better balance at extreme altitudes, allowing interception of targets that even some larger NATO fighters struggled to reach. Then came engine noise reduction modifications, not acoustic quieting for human ears, but disruption of automated tracking systems. Rolls-Royce altered internal components so the engine emitted fewer stable frequency bands, reducing detection reliability for acoustic tracking. Drones. In certain scenarios, the Gripen could penetrate drone defense grids without being flagged as a priority target. And for countries dependent on automated air defense systems, this represented a significant and dangerous vulnerability.